Good morning, students. Today we will be continuing with mechanization and automation, but the scope will be different. Here we would be analyzing the type of welds in ships. The basic idea is that to understand the area where we need to give emphasis for mechanization and automation. So this is a data which I got from a book, which is basically not a textbook. It's a what do you call a survey report. Surveys done on around 60 different shipyards worldwide, which includes Japanese, Korean, then Chinese, European, and even US shipyards. Definitely, Indian shipyards were not part of the study. And from this study, it is found that for bulk carriers, and therefore, especially for bulk carriers, 74% of the total weld length is taken by flat horizontal fillet welds, whereas only 4.8% of the total weld length is taken by butt welds, and 18% is catered by vertical fillet welds. Frankly speaking, it was quite a revealing thing for me personally to realize that almost 74 to 18, 74 18 means 92% of the total weld length of a ship is fillet weld. The reason why I was quite surprised was that you see, I was handling structural repairs for the past 7 years. The bulk of the attention is paid only to the butt welds, because these are the most critical joints which joins two different plates to form a single plate. And these are the areas where we do almost all the NDTs like radiography, liquid dye penetrant test, magnetic particle test, then UT gauging, ultrasonic testing. All these tests are basically done on the butt welds because these are the most critical joints. But if you consider the total weld length of a ship, it is found that 92% of the total weld length is taken by fillet welds, where we do not pay much attention to, because these fillet welds are those we use to join stiffeners on the shell plates, decks, bulkheads. Then fillet welds are used to weld bulkheads over the decks, and for all other connections as well. And the the good thing with this study is that it enables us to identify the most repetitive and frequent types of weld for which priority has to be given for mechanization or automation. Because whenever we need to adopt mechanization in an industry or automation in an industry, we need to identify those areas which are repetitive in nature and which can be easily automated. So this fillet welds falls into that category that category. So the most repetitive and frequent type of weld being horizontal fillet, which caters around 74% of the total weld. First priority for mechanization shall be given for this type of joints. So we will be analyzing the trends of automation or trends of mechanization in joining various parts of the ship. Technically, I don't know whether it is purely technical, but in most of the books we can find that seam welds and butt welds. So initially, when I joined shipyard, I also didn't quite understand what exactly do these people mean by seam welds, because for me, when I completed my post graduation in welding, um, seam means weld seam. For me, it was like all the welds were having weld seam. Weld seam means the total profile of the weld. But in our shipyard, the seam welds are basically representing the welds which are longitudinal to the ship, which is along the length of the ship, whereas these butts are transverse. So the following types of wells and its locations will be analyzed to understand the trend of automation and mechanization in shipyards. So to begin with, we will discuss about bottom shell, both butt and seam welds, welds at bilge strake, then welds performed in side shell plates, both butt and seam welds, and welds performed on the deck, or basically it can be a tank top as well, in both butt and seam welds. So this is a midsection of a midsection of a ship. Here we can see various type of joints like but BB, you can understand like BB will denote bottom plate butt weld, BS will denote bottom plate seam weld, then NS can be understood as tank top seam weld, NB can be represented as tank top or deck butt weld. This B will be bilge strake. HS would be side shell or hull seam weld. HB would be like hull butt weld, and etc. This was just for understanding various types of joints. You can use this, you can understand this figure um, easily. So if you analyze bottom shell, butt and seam weld, this bottom plate is very critical, and for high productivity, what we use is we prefer flat position. Flat position means downhand. Downhand. If you recollect, in our initial class itself, I had told about weld positions. This flat position, you just understand that we will be welding in the direction of gravity. That means in like writing on a piece of paper on a table. Okay, so for high productivity, this is the most easiest weld position. So in order to increase the productivity, we prefer this welding to be performed in flat position. It can happen from inside the tank as well. For double hull ships, the problem is that there will be restrictions in the space available for the welder to perform weld. So there will be a lot of confined spaces, and also there will be a lot of stiffness to strengthen the bottom plate. So this bottom seam in the sense it will be along the longitudinal direction. Basically welded with submerged arc weld or one-sided submerged arc welding, because submerged arc welding it is very easy to depute for flat position in the sense downhand position. One of the major disadvantage of this submerged arc welding is that it is not that efficient, or we cannot use for out of position welds. Bottom butt welding, you understand that it is transfers to the ship, will be done basically with semi-automated gas metal arc welding. One-sided semi-automated gas metal arc welding is also developed and is also used. If you analyze the trend of welding, earlier cases, maybe in the past, if you see, most of the weld would be performed with one-sided submerged arc welding, and it has not changed much presently also. But if you see the trend towards the future, the development in fully automation, this GHA shown in the figure is like highly automated, and GSM is showing will denote simple mechanized. Simple mechanized in the sense, you see, if you have seen a CO2 welding or flux core arc welding performed in a shipyard, the the welder performs the motion of the torch, and that means the weld moves from the welding is performed from one position to other with the help of a welder. But simple mechanization, like providing a weld carriage which have the ability to move the torch with a small oscillation, and this small particular setup, without altering the entire welding process, like without altering the power source, without altering any of the setup, we are just doing a mechanization for movement of the torch with oscillation or desired what do you call electrode tip to metal distance. So this mechanization is not that developed presently, but shall develop considerably in the future. And also the quantum of welding which is performed with highly automated welding processes, like highly automated welding process with FCAW or GMAW is predicted to be more for welding bottom plates, both butt and seam welds. If you analyze build strike is a very peculiar area, because it is welding in that area is slightly complex because it has a curvature, and due to the curvature, the weld position will always change from flat to a vertical position. So here what we find is that in most of, as I told before, we cannot depute submerged arc welding because submerged arc welding will be restricted to flat position. For these curvatures and all, it is always preferred to use semi-automated GMAW or FCAW. FCAW, whenever I am telling FCAW, FCAW is a variant of GMAW. So whenever I am telling GMAW, it is applicable to FCAW as well, because these processes are the same. Only thing is that in flux core arc welding, the electrode core will be having a flux, whereas in GMAW, the electrode will be solid wire. The only difference is that. So in semi-automated, when we use semi-automated GMAW, we have the ease of doing these out of position welds, and due to that, we do not see much changes in the trend in future. However, these highly automated welding processes are being developed, but we do not see abrupt change with regards to the bilge strike plate welding, because if you see here, most of the joints are done with ordinary gas GMAW, and it is expected to be remaining as such. Maybe a slight amount of mechanization would also happen. Simple mechanization is also expected to happen, and but in general, the more or less the same process would continue, but a small portion would be taken by automation, highly automated or simple mechanized building processes. And for side shell, if you see side shell butt plates are like, it will be in the transverse direction. In the transverse direction means it will be always in a vertical position. The plates, the hull plates will be welded vertically. When we are doing this vertical position welds, there are basically um, I have written here slightly wrong. It is basically electro gas. I think it got auto corrected to electrons. So we can use electro gas welding, we can use electro slag welding, and the always preferred welding process of semi-automated GMAW. The process of one-sided semi-automated GMAW is also being used. If you see the trends in butt welding of hull, we can see that the trend is towards electro gas welding, because electro gas welding is a highly productive welding process, and the speed of welding is quite high. The quality is not that compromised, but at the same time, we need to reduce the dependence on manual semi-automated GMAW process. That means we have to do mechanization, simple mechanization more. We have to depute more, what do you see, more highly automated welding processes. But this highly automated welding process is not in the present knowledge. Highly automated welding process is not that developed to be applied to vertical this side shell joints, or side shell butt joints. So the emphasis will be more towards deputing electro gas welding, so that the productivity is more. And one thing is that the selection of electro gas welding, GMAW, electro slag welding will be also depending on the thickness of the metal which is to be welded, because this electro gas and electro slag will be slightly more predominantly used for welding thicker plates. And if you analyze the side shell seam welds, the side shell seam welds will be longitudinal to the ship, and hence will be horizontal. Will be having the weld position will be horizontal. So these are also done either from outside or from inside. Here too, semi-automated GMAW is widely used. One-sided semi-automated welding is also being used. The quality of the weld will depend naturally on the root gaps, root angle, and the change of the geometry. And if you analyze the trends of welding in side shell seam position, it can be highly automated. So the trend would be like more than 50 percentage of the side shell seam welds would be highly automated, and then maybe around 15 to 20 percentage will be highly mechanized. The dependence on ordinary gas metal arc welding, and the dependence on the other welding processes like electroslag welding will be considerably reduced in the future. But presently, around 70 percentage of the, or more than 50 percentage of the side shell seam weld is performed with semi-automated GMAW. If you analyze deck welding, both butt and seam welding, the most preferred position will be flat position. That means we prefer welding downhand. So as a result, SMAW and GMAW is the most widely used welding process, and one-sided GMAW is used for high productivity. Recently, one-sided GMAW is also used. And if you analyze the trend here too, at present, more than more than 50 percentage of the weld is performed with SAW, and in certain cases, like around 15 to 20 percentage will be with SAW as well as ordinary GMAW. But if you see the trends, in future it is expected like more than 50 percentage will be highly automated, and then the usage of SAW will be restricted to around 30 to 40 percentage. So the whole idea of this particular slide was to make you understand how we shall identify the areas for automation and mechanization. In the coming lectures, we will discuss more about mechanization, how mechanization is done, what are the benefits of mechanization and automation, and also we will discuss about robotic welding, the basics of robotic welding, because all these topics are very general in nature. So it is better that we get an understanding of what exactly these are. So thank you for your time. we'll see in the next class. Thank you.